La Fondazione IBSA è nata nel 2012, quando praticamente io sono arrivata in IBSA, quindi è nata un po' con il mio arrivo. E quindi cominciando a lavorare per questa fondazione, come prima attività abbiamo pensato che la cosa più importante fosse proprio quella di aiutare dei studenti o studenti di PhD appena laureati, diciamo giovani con intenzione di diventare ricercatori, quindi di fare ricerca scientifica. Vedere poi la gioia dei ragazzi quando ricevono la notizia di aver vinto questa borsa di studio è un qualcosa che ci fa sentire tutti molto meglio. Si chiamano fellowship perché questo termine è stato coniato negli Stati Uniti. Il significato della parola dà proprio il senso di quello che noi facciamo. Le fellowship sono delle scialuppe di salvataggio, perché il fellow è la persona che lavora in laboratorio. Noi cerchiamo di aiutarli soprattutto in alcune aree scientifiche che sono particolarmente poco finanziate. Sicuramente il consiglio che darei è quello di investire e quindi in qualche maniera sostenere ognuno per le sue tasche, per le sue modalità, per le sue possibilità, sostenere la ricerca scientifica. La ricerca scientifica può cambiare il mondo.
So I have always been very curious, and the desire for knowing things is one of my biggest motivations. And science also provided me with the environment where I can fully embrace my creativity. In my opinion, research is a hope and also a promise for the better future for all of us. Winning the prestigious IBSA Fellowship reward provided me with the financial stability at a very sensitive stage of early career.
Thanks a lot to the IBSA Foundation Fellowship. It gave me the first note from the public, and it's extremely important for a new guy in the field. Not only the financial support for the research work in the laboratory, but also establish the confidence for myself and the advantages for myself when I interact with the people and even applying the new positions in my career.
We do scientific research because we want to see people suffer less. We do scientific research because we want to see people healthier. And we do scientific research because we want to see people heal. So when you look at it from this point of view, research really means caring for others, because all the work we do is eventually about the patients.
La ricerca è un'avventura, è come corteggiare una bella donna, quindi bisogna che continuino a corteggiarla.
Ladies and gentlemen, good afternoon and welcome to the award ceremony of the IBSA Foundation Fellowships. This is our 8th edition, and considering the moment we are going through, we have decided to hold this event online through live streaming. I am currently in Lugano, where the IBSA Foundation has its offices, but particularly where the IBSA Group, the pharmaceutical company that set up the foundation in 2012, has its headquarters. During this short event, we will have the possibility to know and to directly meet the 5 winners of the fellowships of the 2020 call. They are connected from their laboratories or from their research institutes, and later on we will have the possibility to listen to them and to hear about their projects, to congratulate them and to celebrate them all together. Let me grasp this opportunity to say that organizing digital events requires a lot of hard work. It might not appear to be so when you watch digital events, but they really require a lot of organizational efforts. For this reason, I'd like to introduce you my precious colleagues, and I'd like to grasp this opportunity to thank them, Sarah Comodo and Claudia Mazza, that took care about the organization of this event. Thank you very much for this. We hope everything goes well. So for this ceremony, for this event, before meeting the winners, we have decided to take a moment during this initial afternoon to kind of talk and think about the importance of scientific research. Well, we have devoted and we are devoting most of our activities to scientific research, and the foundation is called IBSA Foundation for Scientific Research. Now, to do that, we have an exceptional guest with whom we shall have the possibility to talk about these issues. He is a distinguished scientist, Professor Alberto Mantovani. He is the scientific director of the Humanitas Institute, and he is also Emeritus professor at the Humanitas University in Milan. Professor Mantovani is an Italian scientist. He's very well known throughout the world, and he is one of the most mentioned Italian researchers in publications. Over the past few years, he has taken part in a number of projects of our foundation. Together, we organized a forum on immunotherapy, and he also contributed to the science activity with scientific cartoons. As we shall hear later on, he devotes a very important part of his activity to the dissemination of scientific information also to schools, universities, and young people. At this point, I would like to welcome our professor. Good morning, Professor. How are you? Well, I'm well. Thank you very much. I'm very glad to be part once again of the IBSA Foundation community. It's a real pleasure. Well, we're honored. A lot of people of our company and of our foundation are connected live, and they are looking at this event, and they will hear you. And so they are very happy. Well, we had a number of positive remarks when they heard that you were going to be part of this event. So thank you very much. Before starting our talk on scientific research, I'd like to know what is the general mood, what is the general feeling at the Humanitas Institute. You are dealing directly with the COVID pandemic yourself. Well, at the moment, the general mood is that of those people who are, dealing with a big challenge at different levels. First of all, trying to care for our patients who are infected with COVID-19. We also have a big challenge in dealing with patients who are not infected with the COVID-19. We need to ensure treatments to patients with cancer, vascular diseases, and the central nervous system diseases. So we need to make sure that they are safe. We have then a research challenge. We are studying in all fields of research, genomics, genetic risk, and immunology, and biomarkers as well. We have a research challenge connected to vaccines with, we hope, important results for the health of our European people. A number of decisions taken at European level are related to research made by a number of groups, including our own institute. And so the message is there is intensive research in this field at the moment. And then we have the challenge of the vaccination hubs. We are vaccinating more than 2,000 people a day. On Sunday, we vaccinated more than 30,000 people. And so when I get nervous and I get concerned to relax, I go to the vaccination hub because everything there runs smoothly. And then the challenge of sharing the little knowledge I know or I have with other people. So very, very, a very committed and active person. So we're very glad that you could find some time to be here with us today, but also yesterday for the rehearsals and the tests. So these live events also are charged with stress and nervousness. So thank you very much for being here with us today. So I'd like to ask you first why we are working in the field of scientific research. But why is scientific research important? Let's try and explain this. Why is scientific research important? Well, the scientific research of yesterday, of today, and of the future, and people who are getting this fellowship as well, well, these are our hopes. It's fundamental, I believe, to explain this. I tend to use the image of the safety belt. Research is the safety belt for humankind. I like to think about the whole humankind. And then thinking about the theme of this meeting, I thought about the image of the airbag. Let me give you a couple of examples of why. Now, the mRNA vaccines are the result of scientific research, very high level scientific research, highly risky as well research. These people used to study cancer, and they moved on studying possible vaccines against COVID-19. The image of the airbag came to my mind thinking about a number of studies that we somewhat have forgotten, but without which we would not have antibodies and vaccines against COVID-19. These are studies performed by Barney Graham, and he used on a spike-like protein, which is present in the syncytial respiratory virus. It's a kind of an airbag. It's a kind of a hidden safety which has exploded at the right time. So it is not true when people say that scientific research is more important at the moment. Well, I believe that it isn't more important now. Our life expectation in our countries is above 80 years of age. So this is the result of drinkable water that we now have, but also of the scientific revolution in biomedicine, which has characterized the last century. The pandemic kind of forced us to face up to the need to have scientific research and its importance. And I'd like to go back to what I heard before in the initial video. From this point of view, scientific research is our lifeboat. It's the boat which is saving us in the pandemic.
We decided to use the term social to talk about the social responsibility of scientific research, and this for different reasons. First of all, because the IBSA Foundation has a very important role within the company in the area of social responsibility. Of course, this is not the only thing we do in terms of social responsibility, but it is true that the group devotes a lot of time, money, and human resources both for the foundation and for scientific research in general. We also think that scientific social responsibility has a special role. I know that you often talk about the 3 levels or 3-tier theory. Can you explain? Well, I think that scientific responsibility the social responsibility of scientific research happens at 3 different levels. The first level is the researchers and their code of ethics. And I'll give you an example from the past that has to do with vaccines. Fake data published by Wakers, fake data concerning the link between autism and measles vaccines was very bad for the health of kids all over the world. So ethics in scientific research is crucial. Second level has to do with the object of scientific research. we all think that it is immoral to manipulate the genome to create a superhuman being. We are all in favor about gene modifying research if this is aimed at improving human health. However, we do not want to create and give birth to superhumans. And then there is a third level of social responsibility, and that's my own pearl, so to speak. It has to do with dissemination and taking science to the general public. A philosopher used to say that it's our duty to communicate in the humblest and most clear way possible. And this is what I try to do. I try to be faithful to data. I want to also be faithful to the competencies. And finally, I want to bear in mind the consequences of what I talk, of what I say. Well, so you're basically saying that scientists have a social role. We've seen it as of lately during the pandemic. Researchers have been asked to step out from their labs to come to our homes and explain what was happening. But probably we need better coordination when it comes to scientific communication. My feeling, and that's quite common, I think there was a little bit too much of communication. Probably some of the communication was not in the right direction. So those three levels you described were not actually always there. But this takes me to another topic that has to do with the role of scientific dissemination. This is what we do. It's one of our main tasks. As you know very well, we take care of a number of activities at school level. So it's education to kids, small kids. We think that scientific education should start at an early stage. We try to reach higher education, kids between 11 and 14 years of age, and we do a lot of this. There is a lot of contradiction. We think that researchers should speak and explain more, but when they do that, sometimes they don't use the right language, and this creates a bit of confusion in the past. I absolutely agree with you. I do think that a lot of confusion happened in the past, and probably we should say two things. Well, first of all, scientific communication and scientific dissemination is crucial. You were mentioning cartoons and comics. They are so useful, and it was fantastic for me to interact and work together with the IBSA Foundation on that project, as well as on many other projects. I don't want to judge what other people do. I'd rather look at what I do personally, and I try to stick to data as much as possible. There are many examples when data are not provided faithfully. Whenever I'm asked to talk to the general public, I prefer to stick to general terms, epidemiological curves, focus curves. Well, when it comes to those, there are people who are better placed than I am. When I'm asked to talk about thrombosis, for example, and this has been the case over the last few days, well, I talked to Dr. Corrado Lodigiani, who's an expert in the field. So the credit should go to him. And finally, we should always ask ourselves about the consequences of what we say and disseminate. You were mentioning schools. Well, schools is the place where scientific education should happen. Well, before closing this session and before going to meet the winners of our fellowships, could you give us some examples of very bad scientific communication? I don't want to scare our audience too much, but maybe you have a few anecdotes for us. Let's talk about data, and let's go back to the very beginning of the pandemic. And I have also more recent data. Being faithful to data means that there is no data coming from control tests that hydroxychloroquine had some antiviral effect in a relevant model. And people went out to buy to use hydroxychloroquine, and this was because of the very bad communication and information. And we have lots of data. And then hyperimmune plasma. Clinical tests on hyperimmune plasma have not been successful. Well, it's fair to say that we learn from mistakes. So we should wonder, why were they not successful? I do have my own opinion on the topic. More recently, we were very worried, and we wrote about it on a scientific journal, about the use of cortisones, and this outside the window where they are effective. We know that they were able to reduce mortality if they are used when in a specific time window, i.e. when used at in the right window. But sometimes they will be used on an early stage, and that's not good. And then there is a second issue. It has to do with competence. In the past, we have heard about people talking about a non-aggressive virus, a subdued virus, but there was no scientific data supporting these statements. And again, there were people talking about the fact that the pandemic was about to be totally over. No, social responsibility means wondering what's the effect of my own words on people's behavior. If you give me one more minute, I'll give you a recent example. Vaccinating people who have already gone through COVID, well, we've published and we've made our scientific data available to everyone. Well, there are no doubts that those who underwent COVID has an 80% expected protection from COVID. However, in the largest population that was studied in Denmark, 4 million people, data says that the protection for those over 65% is only 47%. So the message is, please get your jab. The jab is the best protection you can get. So these are examples that should make us wonder, are we actually disseminating the right message, inducing the right behavior among people? So to conclude, we can say that the social role of scientists is that they are the only ones who can really say whether a piece of research can be disseminated on social media, or whether it should stay within the walls of the scientific community, because it's just the scientific community who's able to understand whether those figures are enough to lead treatment in one direction or the other. So sometimes I'm asked, what's the best recipe for scientific dissemination? Well, I have no idea how to answer to this question. Probably what's the best thing to do is start from scientific data, scientific research work, and decide what are the topics to be disseminated and which are not to be disseminated. It's not easy. In the past, we used to speak less about scientific research. As of lately, we have been speaking a lot, particularly after the outbreak of COVID, and therefore there is a lot of noise. Yes, indeed, there is so much talking going on. And I also think that probably we did not talk enough about the tools that enable us to really analyze information. This is the reason why I like going to schools, meeting young students. I've always accepted invitations that are sent to me to talk in schools. People very often do not have the right scientific tools to understand scientific data. There is a lot of talk between risks and returns. I do use paracetamols quite regularly, and probably this is one of the safest drugs we have. It's been around for more than 100 years. But I do know what the risk is, hepatotoxicity induced, paracetamol-induced hepatotoxicity. But people are not used to really understand the cause-effect ratio. Or, we are all lovers of our Italian soccer team. And if I say Buffon was a fantastic goal scorer, well, everyone will wonder what happened to me. Everyone knows that he was a goalkeeper. Well, Professor Mantovani, thank you very much for being with us today. I know that people will have hundreds of questions to ask you. Unfortunately, we do not have time for those many questions. It would have been fantastic to have you here with us in Lugano. It would have been so nice. Unfortunately, that was not possible. I might send you a few questions via email. So I must go now. Thank you very much for being with us today. And we can now continue with a message from Arturo Licenziati, who's the president and the founder of the IBSA group. He's done so much for our foundation, and he sent us a video recorded message. Thank you very much, Professor Mantovani. And see you soon.
Perché sosteniamo la ricerca?
So why
Perché
do we
la luce
support
che guida il
research?
nostro
Well,
lavoro
because it's
è
the beacon
l'innovazione, e
guiding
quindi
our
ricerca.
work. And
Per
this
fare la
beacon is
ricerca
innovation,
bisogna
hence
conoscere chi è
research.
l'interlocutore, che
In order
cosa
to do
ricerchiamo
research, you
per
really have to
migliorare la
understand
loro
who
vita.
your target
Il nostro
audience is and
obiettivo
what
è
they
il
need and what we
l'ultimo
can do to improve
consumatore,
their
quindi
life.
migliorare la sua
Our
vita.
main target is improving their
Questo
life.
lo facciamo
So we
in
do
modo
this
piccolo, perché
as we
chiaramente
can.
non siamo
Of
il
course,
mostro sacro dell'industria
we
e
are not
possiamo destinare
perfect
solo
in the
piccoli
industry, and we can devote only
contingenti
a
economici per
small
poter dare una
part
mano ai giovani.
of our financial
Ecco, il
resources to support
nostro
the work
contributo
of
ai
young
giovani
people.
ci
So
ripaga perché se
we
riusciamo
want to help
a
young people
stimolare
because
in
if
modo
we succeed
particolare
in
dei giovani
stimulating
ricercatori siamo soddisfatti.
the work and supporting and enhancing the work of young people, it will be mission accomplished.
Thank you very much. I know that you are listening to us. So thank you very much for your message and for the constant support that you give to our activities, not only in supporting the whole IBSA group, which is already quite a huge task, but also you support the activities of the IBSA Foundation. At this point, we get into the core of the foundation or the award ceremony. 5 winners. Here you can see the data of the 2020 call, 8th edition, 5 fellowships, each worth 30,000 euros in the following research area: dermatology, endocrinology, fertility, urology, orthopedics, pain management, and rheumatology. The latter 3, we put them together to provide greater help and also to place the projects in the correct scientific area. This special edition is devoted to coronavirus infections. Now, we have received 162 projects from all countries of the world. As you can see here, some 36% more compared to the previous year. And this is a very good result in terms of, spreading of our activity and of our project. Now, as usual, we have a difference between women and men. We now have more women doing research at the moment, or at least we have more young women who get into research. Perhaps then they got lost in the research path, because data tell us that when it comes to top positions in research institutes, you still have men. So that's only a social note. So in our experience, in our project, endocrinology is the most popular field for which we receive the highest number of applications. Now, let me also say, and go back to our video, we have chosen these scientific areas of research because they are not very much supported by grants or fellowships in these areas that you see listed here. For instance, oncology receives more support, diabetics as well, and also as of late, viruses, vaccines, and virology in general is receiving more support. So we're very proud of offering fellowships in these areas. So let me try and tell you how we screen or how we assess our projects. Quite a difficult stage, I have to say, of our work. We work with our scientific board. Here are the members of our board, especially for those of you who do not know these people. We have 4 university professors as members of our scientific board. Professor Andrea Alimonti, professor of oncology in 3 universities, the University of the Italian Swiss, of the ETH Zurich, and the University of Padua. Antonio Musaro, full professor of histology, embryology, and biotechnology at the Rome La Sapienza University. Professor Bruno Imthorn, professor emeritus of endocrinology and reproductive medicine at the University Hospital of Zurich, and Professor Domenico Salvatore, full professor of endocrinology at the University Federico II of Naples. These are 4 university professors, and they devote a lot of their work to teaching, but they are mainly researchers, scientists. Now, and they at the moment are head of labs or of institutes or of departments. So these are 4 scientists who have frequently written projects to obtain themselves grants, but they very often are called upon to assess projects of other people for other calls. So what we do together as a scientific board of the IBSA Foundation is that of assessing any single project. And a project would be evaluated about originality of the choice and of the research project, and then the innovative potential of the project, the scientific value, therefore the scientific excellence, and feasibility. When I say feasibility, I am referring to the real possibility to carry out that project in a period of 12 months. We award a fellowship to young researchers, and we do not want to receive large projects which perhaps have already been submitted for large grants and which are already there sitting in the different research labs or different research institutes. So on the contrary, our fellowship call aims at awarding or helping young researchers. Of course, we also take into account their experience in terms of recent publications, and also we take into account the appropriateness of the research institute in which they work, because they need to be placed in the necessary conditions to carry out the project which is awarded a fellowship. So the IBSA Foundation Fellowship is a kind of a salary, so it's money allowing these young candidates to work for a year. The research institute itself has to guarantee them the possibility to carry out the research that we have awarded. The 5 projects we awarded the fellowship to are all very highly innovative as to their potential, and they all have a great scientific excellence. Well, I have to say that this year the choosing the projects was not easy. The board members independently assess the projects, then we meet and together we identify the winners. And sometimes the discussion is lively because the themes, the topics are different. Technologies are very much advanced, and it's not difficult to discriminate between the projects. But at the end, we are very glad to award today Akiko Mori from the Padua University this award for the dermatology area, and she will be telling us about her projects about mitochondria and stem cell. And then Ian Kroon from the Netherlands, the Leiden University, for the area. He competed for endocrinology. He deals with glucocorticoids treatment. As you know, glucocorticoids have a number of positive effects, but also, alas, a number of side effects. And this project aims at reducing such side effects. And then Sarah Credenti from the University of Naples, Federico II. Urology is the field of her project. It's about fertility. Very interesting. You will hear her the effect of airborne pollutants on the reproductive capacity. Then Anna Griadunova, University of Basel, for the area rheumatology, pain management, and orthopedics, and she will be talking about regenerative treatment. Very highly technological project to deal with the rupture of intervertebral discs that may lead to a lot of low back pain in a number of patients. And then Ying Kong coming from the University Medical Center of Groningen, the Netherlands as well. And in this case, special edition area, coronavirus infection in this case, and she will be telling us about a technique that they have identified to strike the coronavirus at the heart, because they're trying to impair viral replication. At this point, I'd like to call Akiko Omori. She will start, and they will tell us very briefly about their project, and they will hand over the microphone to the next winner. So Akiko Mori, you have the floor.
Thank you for the organizer of this ceremony, and thank you for your kind introduction, Dr. Misiti. My name is Akiko Omori. I work as postdoc in the Veneto Institute of Molecular Medicine and the Padova University. Today, I would like to present my project, exploring the role of mitochondrial morphology changes in melanoma stem cell, applied to the field of dermatology. I got my PhD in Japan and then came to Italy to study mitochondrial analysis in Professor Scolano lab. I would like to thank IBSA Foundation for their support of my research. This prestigious award not only personally support me, but also increase my future career prospects. My project focusing on what we think is a novel angle in the biology of melanoma. Despite recent breakthroughs in the melanoma-targeted therapy, the prognosis of metastatic melanoma remains poor due to the development of drug resistance. The ability of cancer stem cells to evade immune surveillance and chemotherapy appears to play a crucial role in drug resistance development. Nevertheless, how cancer stem cell character is sustained is still unknown. In our project, we wish to address the role of mitochondria, the energy plant of our cells, and a key organelle in cell metabolism and survival in the establishment and maintenance of melanoma cancer stem cells. Mitochondrial function depends on mitochondrial shape changes controlled by mitochondrial shaping proteins. We recently discovered a role of OPA1, a key mitochondrial shaping protein, in melanocyte biology. OPA1 is essential for melanocyte stem cell maintenance. In fact, abrasion of OPA1 in mice leads to premature hair graying. We know that this is due to a loss of melanocyte stem cells. Based on these preliminary results, I now aim to extend my findings to study how OPA1 is required for the growth and metastatic melanoma and regulation of melanoma cancer stem cells. First, we would induce melanoma stem cell in culture and then analyze mitochondrial shape changes in these stem cells and analyze by unbiased approach of differential proteomics and metabolomics. Whether and how melanoma stem cells depend on OPA1, for which the host lab has discovered a specific molecule inhibitor. The long-term aim of my project is to identify and characterize the role of mitochondria and of OPA1, specifically in the generation of chemoresistance melanoma, with the prospect to provide a novel therapeutic target for this untreatable disease. Thank you for your attention. I'm pleased to give the word to my fellow winner in the endocrinology field of the Dr. Jiang Lun.
Thank you. So firstly, I would like to thank the IBSA Foundation for selecting my proposal as the winner of the Endocrinology Fellowship 2020. I'm Jan Kroon. I'm a postdoctoral researcher from Leiden University Medical Center, the Department of Endocrinology, in the group of Professor Onno Meijer in the city of Leiden, the Netherlands. The main objective of my IBSA proposal is to better understand how glucocorticoids causes side effects. Glucocorticoid drugs are synthetic versions of our stress hormones and have very strong anti-inflammatory activity. For this reason, millions of patients worldwide rely on the use of synthetic glucocorticoids, for example, for diseases as rheumatoid arthritis, multiple sclerosis, and inflammatory bowel syndrome. But unfortunately, glucocorticoids are notorious for their side effects, and many people that take glucocorticoids experience muscle weakness or diabetes, amongst many other side effects. In this project, we want to understand how glucocorticoids cause these side effects. For this, it's important to know that glucocorticoids activate the so-called glucocorticoid receptor. And the glucocorticoid receptor is expressed all over the body. And while it is almost everywhere, it does act a little bit different in different tissues and in different cell types. Or in more technical terms, the effects of the glucocorticoid receptor are strongly dependent on interactions with known and unknown proteins, the so-called cofactors. What I intend to do in this project is to identify which cofactors are responsible for the side effects that are caused by glucocorticoid liver on muscle and on liver. I will investigate 3 very frequently used glucocorticoid drugs that all are known to cause side effects. And by using a novel technique, I will be able to identify precisely with which cofactor proteins these glucocorticoids interact. And by comparing the cofactor profiles of the 3 clinically used glucocorticoids, we may be able to identify the cofactors that are responsible for the side effects upon glucocorticoid treatment. After using this strategy to identify these factors, we have to confirm their involvement, and we will do this by generating cells that lack the expression of the cofactor proteins that we identified. Our expectation is that the removal of these cofactors will prevent the activation of genes that are involved in the side effects of glucocorticoid treatment. Altogether, I believe that this project will greatly increase our understanding of one of the most clinically used classes of drugs, glucocorticoids. And by better understanding the cofactor proteins that cause the side effects, we may also be able to improve our current glucocorticoid treatment by maintaining its beneficial glucocorticoid properties and bypassing the side effects that they cause. I want to thank you for your attention. I'm now pleased to give the word to my fellow winner in the fertility area, Dr. Sarah Credenti.
Thanks, Dr. Krohn. Good evening, everyone. I am Sarah Credenti, postdoc researcher at the Department of Molecular Medicine and Medical Biotechnology at the University of Naples, Federico II, where I also obtained my PhD. Today, I'm pleased to present to you my project entitled The Direct and Transgenerational Effects of a Common Air Pollutant on Mouse Fertility. This project starts from the evidence that chemicals are including air pollution, have a considerable role in the reduction of both gender fertility, particularly in industrialized countries where they are mostly found. They indeed represent the source of the so-called endocrine and disrupting compounds that alter endocrine and reproductive function, affecting hormone action and germ cell physiology. Among these compounds, benzoypyrin, that we will call BAP, deserves particular attention because it originates from both human activities and natural processes, so it can be reduced but never be completely eliminated. It has been demonstrated that BAP exposure during adult life affects reproduction ability, and that fetuses and infants are particularly vulnerable to BAP exposure that at this stage of development causes several disorders, also affecting fetal viability. However, the effects of BAP exposure during fetal and infant life on the newborn fertility are still poorly described. Therefore, my aim is evaluating direct and transgenerational effects on mouse fertility of BAP exposure since the intrauterine life. To this purpose, BAP will be administered only to pregnant mothers of the parental generation. Of the parental generation until the end of breastfeeding. And then to pups of the first generation up to 5 months of age. We'll then perform biochemical and molecular analysis, dosing hormones such as androgens and estrogens, and performing biochemical, histological, and molecular analysis on male and female gonads. This kind of analysis will be performed until the 3rd generation, allowing mice to reproduce without further BAP exposure. Also evaluating reproductive performance parameters, such as the frequency of productive crosses, the numbers of litters, and pups per litters. This detailed characterization will identify the crucial steps of fertility processes affected by BAP. Moreover, the comparison of the data obtained from both directly exposed individuals and their descendants will allow me to distinguish between the direct and transmitted fertility defects. My goal, indeed, is also to identify the targets mediating BAP effects, connecting molecular defects with clinical outcomes. And thanks to this IBSA fellowship, I could shed light on the effects of such common pollutant on reproductive fitness through multiple generations after exposure, opening in this way novel perspectives for the safeguard of the human reproductive health. Thanking all of you for your attention, I'm now pleased to give the word to Dr. Anna Griadunova, the winner in the area of orthopedics, rheumatology, and pain medicine.
Thank you very much, Dr. Sarah. Welcome, everyone. My name is Anna Griadunova, and I am a PhD candidate from Sechenov University, Russia, and also a guest researcher at the University of Basel, Switzerland. First of all, I would like to thank the organizers of this event for this tremendous opportunity to be here today. It is my extreme privilege to be here and to present our project to you. So, our project, entitled NanoGhosts as Gene Delivery Platform for CRISPR Components in Intervertebral Disc Repair, focuses on the repair of degenerated nucleus pulposus, the inner part of the intervertebral disc. Intervertebral disc degeneration is characterized by the breakdown of one or more discs that separate the bones of the spine. Despite the large need, a regenerative therapy for such conditions still doesn't exist, also due to the harsh microenvironment that inhibits self-repair capacity of the cells. In order to overcome this limitation, we can enhance this capacity by increasing cells' behavior in such condition. Therefore, the purpose of our project is to modulate gene expression of GDF5, a factor that plays an important role in the maintenance of homeostasis of the disc, and we are planning to do so by applying a novel approach known as CRISPR activation. And to do this, to apply this approach, we would need to introduce and deliver some specimen to some substances inside the cell. And in order to do this, we are planning to use nanoghosts, which are nano-sized vesicles derived from plasma membranes of the cells. So we are planning to prepare these nanoghosts from mesenchymal stromal cells, then load them with the components needed for CRISPR activation. And after that, we are going to characterize them, their properties, cellular uptake, and bioactivity using human nucleus pulposus cells cultured as spheroids, as well as an ex vivo model of the whole bovine IVD, intervertebral disc. The concept evaluated in this study is very important to the personalized medicine, and thanks to IBSA Foundation, we are planning to be the first ones to use nanoghosts for the delivery of large components for CRISPR in nucleus pulposus. And we hope that this project will facilitate gene delivery and engineering based on patient-specific background. Based on patient genetic background, and represent the first steps towards patient-specific therapies in the field. So we believe that it will help to transform the healthcare system into a more efficient and patient-centered environment. And with this, I would like again to thank the IBSA Foundation Board for this opportunity to be here and for their support. I would also like to thank the whole Tissue Engineering Lab from the Department of Biomedicine, University of Basel, and in particular, Dr. Olga Krupkova, who awarded the same fellowship 5 years ago and was a great help for my project proposal, as well as Dr. Professor Ivan Martin, Professor Andrea Barbero, and Dr. Arne Merkens for their support and supervision. And I would like to finish with this powerful quote from Nelson Mandela: "It always seems impossible until it's done." Thank you for your attention. And now I'm very pleased to give the word to my fellow winner in the special edition COVID-19 area, Dr. Yin-Yang Kong.
Thanks very much to Anna. My name is Yin-Yang Kong, a postdoc researcher in the laboratory of Professor Fulvio Raggiori at the Department of Biomedical Sciences of Cells and Systems of the University Medical Center Groningen, the Netherlands. Thanks for the board of IBSA Foundation to choose my project and to give me the opportunity to identify compounds that have the potential to inhibit coronavirus infection by targeting the first of their life cycle in University Medical Center Groningen. Since emerging around December 2019, COVID-19 has progressed rapidly into a pandemic. Although vaccines against coronaviruses are a good preventive approach, and a few of them are currently being used to prevent the further spreading of COVID-19. Anti-coronavirus drugs are a good therapeutic alternative, especially for people that get severe infections. Many anti-coronavirus compounds have also the added value that they will be very valuable to treat diseases caused by coronaviruses that will emerge in future and for which we may not have a vaccine immediately. Replication is a fundamental aspect of the viral life cycle and is mainly mediated by viral non-structured proteins. As replication is essential for viral survival, viral proteins involved in replication are highly conserved and not impacted by mutations. Among these, we have recently shown that the interaction between of them is essential for the coronavirus replication, and blocking this interaction practically kills the virus. Together with my colleagues, our plan now is to set up a miniaturized assay to be able to rapidly screen thousands of compounds and identify compounds that could potentially block the interaction between these two viral proteins. Then, the isolated compounds will be tested for their capacity to block the infection by SARS coronavirus 2 and, of course, other coronaviruses in cells. The most promising compounds will be further studied at the structural level to determine their mode of action. We expect to identify drugs to fight the current and future coronavirus outbreaks. Thank you for your attention, and I will give the word back to Silvia Misiti.
Grazie a tutti.
Thank you very much to all our winners. You have been clear, to the point, quick, and of course, all those who are interested in your project will write to us, and we will create a dialogue between you and them. The IBSA Foundation is always very keen to keep in touch with our award winners. We are interested in knowing whether they were able to continue with their research work or if they were forced to change the area of a study. We also want to understand whether our fellowship have been important for their life or not. We know that the first and the second fellowship for many people has always been crucial for the career development of our researchers. I think we will meet again in 1 year because we are now officially opening the new before tender for our award. And I'd like to finish this session with a video. But before we launch the video, I want to thank everyone, those who have been involved in the organization of this very intense day. I think it all went very smoothly. Of course, your critics will be welcome. So see you soon.
Siamo molto felici e orgogliosi di svolgere questo ruolo al servizio della Fondazione IBSA e di poter dare l'opportunità a dei giovani ricercatori di poter essere supportati soprattutto nelle fasi iniziali della loro carriera. La fellowship è aperta praticamente a tutti, quindi non c'è limitazione né di regione o di appartenenza geografica, religione o altro, quindi tutti i giovani di tutte le parti del mondo possono applicare. Esistono questi 3 criteri sul quale noi ci basiamo, che sono appunto l'eccellenza scientifica, la fattibilità e il potenziale innovativo. Lo scorso anno abbiamo deciso di dedicare una fellowship al tema dell'infezione da SARS-CoV-2, che ci ha ovviamente interessato tutti quanti, sia come comunità scientifica che come normali cittadini. Il numero delle application in questo settore è stato ampio. Quest'anno abbiamo deciso insieme agli altri membri del board scientifico di aprire quindi una call per una fellowship al tema della medicina rigenerativa. A me personalmente una fellowship ha cambiato la vita.